We're going to discuss again from your module 4, we're going to discuss about LAN and MAC addresses. So we are all familiar with your MAC address. You have a 48-bit MAC address that is going to be your top. And the look of how your MAC address is almost this particular form. So 1A2FBB7609AD. And if you check what your MAC address of your laptop, of your desktop, or your mobile phones, you can see that. So if you want to communicate, you need to have a MAC address. But the most common one is a broadcast address. If it's a broadcast address, that means I don't have a specific source. I want to transmit the information to all, then my address, MAC address would be FF, all Fs. So the green shade shows the adapter. So and it is via the adapter you're connecting to a wired or wireless networks. So this is the basic LAN structures and how they are connected to a particular network, whether it is wired or wireless. Ethernet, we have already seen or we have already heard the normal simple wired network is called an Ethernet. And you are going to connect it to you're going to connect your device to the Ethernet via network interfacing card. Now, if your laptop, you're not able to see it, but it is basically in a point where you're connecting your RJ45 cable, your network cable. It was the most similar structures, and no, you can see the speed up to gigabits per second now. Originally, it started with 10 megabits per second. Now, one question that can come is basically tried nodes about the Ethernet frame. So your Ethernet frame is in this particular form. Basically, you have seen that when you talked about the data link layer. So we said that your data link layer has a header and the trailer part. So this is the data, and the header has basically the preamble, the destination address, the source address, and the type in the most simplest form. And the trailer part has the CRC or cyclic redundancy check or error checking codes that you have over there. The preamble is basically a 56-bit 7-byte pattern alternating between 1 and 0. So 10, 10, 10, 10, followed by 1 byte with pattern 10, 10, 10, 1, 1. So you have all these things, what you see, and you finally will be having this particular pattern. So this is basically the preamble. And basically, this is used for synchronization and all those structures. So we have a preamble, destination address, just like what you have seen over here. This can be the source address. So if this fellow wants to communicate here, this will be the source address, and this will be the destination address. So that will be what we're going to type over here. And we have the CRC over there. The type basically says that whether it is an address resolution protocol or reverse address resolution protocol and all those things. We'll talk about that in another video. So you have that as type, and CRC is the error checking code that is used to see if your transmitted data is perfectly transmitted. Ethernet basically is a connectionless structure, so you don't have any handshaking between sending and receiving network interfacing cards. And basically, it is unreliable. And the protocol that is used is an unslotted CSMA CD structure. So basically, you don't talk about unslotted. You can just generalize and say CSMA/CD. Now, what is basically CSMA? You can say that it checks whether the channel is free. So you start with your interface. Your network interfacing card receives a datagram from a network layer, creates a frame, all those things, basic stuff that is there. Now, if you want to transmit, you want to sense whether the channel is free or not. So it sends whether the channel is free, and if it is free, starts transmission. If the channel is not free and busy, it waits for the channel to be idle and then transmits. Now, if you transmit the entire frame without detecting any transmission errors, then your transmission is done. If the transmission detects another transmission while transmitting, it aborts. So that is what you've seen in the CSMA/CD. It stops its transmission, aborts, and sends a jamming signal. And after that, it waits for some duration of time. This is basically an exponential backup. We talked about exponential backup in year 802.11 also at that particular point of time also. This is basically exponential backup. Now, what happens is that you have this particular factor. How much time do you want to wait? So it will be basically k into the time that you have. k into 512 is the value that you're going to take over here. It can be anything. Just say that no, if it is some other time values, it can be some other time values also. But basically, what happens is that if it is just say if it is the first position, what happens is that you'll be taking random values from 0 and 1. If it is a second position that you come across, you'll be taking values from 0 and 0, 1, 2, 3. If it is the third position, you'll be taking from 0 to 7. Now, if it is a fourth, you'll be taking from values from 0 to 16, and it goes on like this. So in between any point of time, you might be coming across correctly. So what does it mean? So if you have two stations, say station A and station B, station A can take values 0 or 1. Let's assume that it takes 0, whereas B takes value 1. So the wait time for A is basically 0 into 512, whereas second milliseconds or whatever it is. And for B is basically 1 into 512. So that is why the difference is. Again, at this particular point of time, just say that B or A senses collision with C. There's another node also. What happens is that A goes to and checks, go for backup. But what is the set that is going to choose? It's going to choose 0, 1, 2, and 3. So A will be taking values from 0, 1, 2, and 3, whereas C will be taking sets from 0 and 1. Just say that here A takes 3, so it will be waiting for 3 into 512, whereas C just waits for say it takes 0, 0 into 512. So at the next instance, C transmits, and whereas this fellow waits for 3 into 512, that is almost 1500 times. So this is what you mean by exponential structures. Why? Because first was 0, 1, next was 0, 1, 2, 3, next was, so it's almost the double versions of it. So an example to that bit time, how do you see if it's a 1 microsecond or 10 megabits per second? Your K would be 1023. Okay, an example to you can browse through this particular PPT to get a better understanding. The efficiency of this particular structure CSN is your propagation delay, your transmission delay. Efficiency is 1 by 1 plus pi into propagation delay divided by transmission delay. There are different standards to it. I'm not spending too much of time. You have different standards, basically 100 base TX, 100 base T2, 100 base FX, 100 base T4, SX. Now, all these X and all those structures specify if it's whether it is optical and all those things. So we can go through and read that particular structures over there. T4, all those things specify it as a restricted.